Welcome everyone, and welcome to the AluVET Vocational Training and Education for the Aluminium sector. This training is co-funded by the Erasmus programme of the European Union. I am Jan Lukaszewski, the Technical Manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explains the simple theory of metals and of metallurgy to enable students in subsequent modules to understand aluminium, its alloys, how aluminium is heat treated, and how it is rolled, extruded, and/or welded. This project is funded with the support of the European Union. This publication reflects only the views of myself and the Aluminium Federation, and the Commission cannot be held responsible for the use which may be made of the information contained therein. This module will teach you how to heat treat, that is, strengthen or change the mechanical properties of heat treatable aluminium alloys. In this module, aluminium heat treatable alloys, you will learn which alloy series are heat treatable and about the different tempers. You will understand how to heat treat heat treatable aluminium alloys, how through heat treatment you can change the mechanical properties of heat treatable alloys. You will gain an understanding, insight of the principles of age precipitation hardening. You will be able to specify the correct heat treatment to develop the required properties for your products. Now, please understand that this module uses very simplified explanations of solution treating and age hardening and age or precipitation hardening. It is intended to provide sufficient understanding of how age hardening is carried out and its effects, rather than a full metallurgical explanation of the actual mechanisms. Now, the 2000, the 6000, 7000, and some of the 8000 aluminium alloys can be heat treated or can be strengthened through heat treatment. Aluminium alloy heat treatment is called age hardening and/or precipitation hardening. The two have exactly the same meaning. In heat treatable aluminium alloys, alloying elements combine with aluminium during heat treatment to increase the strength of the alloys and change their properties. In the alloy series 2000, copper is the alloying element. Two elements combine in the alloy series 6000 series, magnesium and silicon, and zinc is the alloying element in the 7000 series. The 8000 series group use other elements, but mainly lithium and also tin. European standard EN 515 describes all the possible heat treatments and methods of strengthening aluminium alloys. The different aluminium heat treatments are termed tempers. The European standard EN 515 lists all of the commercially available tempers and summarizes their methods of strengthening aluminium alloys. This standard EN 515 is applicable to all forms of wrought aluminium and aluminium alloys. In the European standard EN 515, additional designations are added after the 4-digit, the 4-number alloy chemistry designation to explain how the physical properties of wrought aluminium alloys are modified by heat treatment and/or mechanical treatment. 6063 is the chemical numerical designation. So we add the heat treatment letters and the numbers after the chemical designation. The first letter of the temper designation indicates the treatment used to produce the properties. Letter F says this is as fabricated, so no heat treatment or strain hardening has been applied. Letter O says that this is in the annealed condition. The letter W says this is in the solution treated condition. This applies only to heat treatable alloys which have been solution treated. And finally, the letter T says these alloys have been heat treated. Now, this applies alloys strengthened by heat treatment. The 2000 series, 6000 series, and 7000 series, and some of the 8000 series only. Remember that the alloy series 1000, 3000, 4 and 5000 cannot be heat treated. The European standard 515 uses the letter T to indicate heat treatment. The European standard 515 uses the letter T to indicate the heat treatment, followed by one or more digits, numbers. The second digit, a number, explains the actual heat treatment. The letter T followed by the number 1, so T1, indicates that the alloy was cooled from an elevated temperature shaping process and naturally aged. Similarly, the temper T3 indicates that the alloy was solution treated, cold worked, and naturally aged to a substantially stable condition. We shall explain the actual heat treatment in the following slides of this module. So thus T4 was solution treated, naturally aged to a substantial condition. Tempers T1 to T4 are natural aging tempers. T5 and higher, so T5, T6, T7 and higher, are artificially aged. And again, we shall shortly explain. So T5 was cooled from an elevated temperature shaping process and then artificially aged. T6 was solution treated and then artificially aged. And T6 is the strongest temper, highest strength temper, and has the lowest ductility. As aluminium heat treatment is an aging process, tempers above T6 are said to be overaged. Hence T7 is solution treated and overaged stabilized. Now please remember that the European standard EN 515 lists all the possible heat treatments and tempers. So let's see how we heat treat alloys. Now, heat treatable alloys have limited solid solubility of their alloying elements. And in our examples, we shall consider copper. So this means as the alloys cool from the liquid state during solidification, during casting, to form solid solutions, the excess alloying elements in our example, copper, are pushed by the growing grains into the grain boundaries, as we saw in earlier modules. In the normal state of heat treatable alloys, some of the alloying element atoms, for our example copper, exist within the aluminium grains, but the excess beyond the solid solubility limits are held within the grain boundaries. So in this schematic, we see that the excess copper atoms, the copper atoms in excess of the solid solubility of atom within the grains are actually seen in the grain boundaries. Now, such structures are weak and very ductile. Just to clarify, in heat treatable alloys, the alloying elements beyond the solid solubility, that is beyond which the aluminium grains can naturally hold the alloying elements, are pushed during the solidification process into the grain boundaries. So the alloying elements in excess of the solid solubility are found in the grain boundaries. Such structures are weak and have good ductility. Increasing the temperature expands the metal lattice, the spacing of the atoms, and so weakens the metallic bond, increasing both the diffusion rate and also the solubility of the solute alloying atoms, as we've seen in previous modules. The solute alloying atoms now can diffuse from within the grain boundaries into the aluminium grains. They are taken into solid solution out of the grain boundaries. So during heat treatment of 2000, 6000 and 7000 series, we increase the temperature of the aluminium to a point where the solid solubility of the aluminium grains increases and the alloying atoms diffuse out of the grain boundaries into the grain.